So many people around the world are struggling with being overweight. The obesity epidemic is a consequence of a food supply that's become essentially diluted of protein. By the year 2030, 1 in 2 people are going to be not just overweight, but obese. 90% of what we know about Alzheimer's disease alone has been discovered only in the past 15 or so years. I actually got to co-author a clinician's textbook on the prevention of cognitive decline. We are going to talk about practical ways to harness the power of nutrition to optimize metabolic health. When do you think digestion starts? The smelling of the food, the anticipation stimulates the flow of digestive juices. Brain health, for every 10% increase in ultra-processed food consumption, there's about a 25% increased risk for dementia. The gut microbiome, by frequently nuking the bacteria that live in your mouth, you're not yielding the full benefit from that cell. 30% of the calories that we ingest via protein are actually burned off via the digestive process. The role of chronic disease prevention, the only dietary pattern that significantly modulates the neurochemistry of the brain. A thorough understanding, a deep dive of how to harness the power of nutrition to attain their health. Welcome, everybody. Thanks for being here. The title of this course, I was trying to decide how I was going to frame it. And so rather than do a deep dive into the weeds of nutrition science, I thought a much better use of your time and my life focus and expertise, I would say, is to really focus on the practical aspects of nutrition. So how to harness the power of nutrition and various lifestyle variables for optimal performance, better health, longevity, and the like. So we're going to focus as much as we can from a high level on the more actionable side of nutrition, which I think is very valuable, right? So we're going to talk about the definition of nutrition. We're going to define it. We're going to talk about the purpose of food. We're going to talk about the various components of nutrition, macronutrients. There's this misconception that to understand nutrition fully, you have to be a PhD or have some kind of, advanced degree. But I think nutrition is something, health literacy is something that I strongly believe we've been disadvantaged because of the way that we've outsourced it, like so many other aspects of life today. We outsource culinary literacy, we outsource financial literacy. When our ancestors were generalists, now we live in the era of specialization, and I think we've lost something in terms of our health, in terms of our appreciation for many of these kinds of topics. And so I want each one of you to walk away from this lecture really having a solid grasp on nutrition and, again, how to harness it for the betterment of your health and the health of your loved ones. Just to share a little bit about my background. So I didn't take the academic path. I went to University of Miami, and then I became a journalist where I worked for 6 years on television in the United States as a journalist, as a field producer. And about 6 years into that role, my mother got sick. My mom developed a rare form of dementia. And I've always been passionate about nutrition science and health to the point that when I started college, I was on a pre-med track. I ended up pivoting out of that. But when my mom got sick, I became obsessed with trying to understand everything that I possibly could about the risk factors that we all are vulnerable to with regard to chronic disease. And so I became obsessed. I dove into the medical literature, and I exploited my title as a quasi-media persona and journalist to reach out to scientists, experts from around the world so that I could learn from them. And so subsequently, I've been able to write a number of books. My first book came out in 2018. It's called Genius Foods. It's now published around the world. It's a New York Times bestseller. And though I'm not primarily a researcher in the technical sense, I have actually been able to publish scientific literature. You can see in the middle section of the screen, on the lower portion of the screen, I actually got to co-author a chapter in a clinician's textbook on the clinical practice of the prevention of cognitive decline. with a focus on conditions like Alzheimer's disease and other forms of dementia. So this is a textbook that actually gets into the hands of clinicians, of physicians, and so I've been able to actually influence the clinical practice of dementia prevention, which to me is super exciting. And dementia prevention, those two words, it's only really recently that we've been able to mention both of those words within the same sentence and be taken seriously. 90% of what we know about Alzheimer's disease alone has been discovered only in the past 15 or so years. So this is a rapidly evolving field of science, but we now know that there are steps that you can take in your day-to-day life that can optimize the way that your brain works and batten down the hatches so that you reduce your risk for these kinds of conditions decades down the line. So everything I do, my why, motivated by the sickness that I saw in my mom. And so, yeah, so for me, being honest, being transparent, and sharing the best available evidence with you guys has become my life's purpose. So psyched to have you guys here. With regard to dementia prevention, just to touch on this, I talk a lot about brain health. That's sort of like my passion. But underneath the umbrella of brain health, you have many different domains that influence brain health. So you have metabolic health, body composition plays a role, cardiovascular health, fitness. Everything ultimately influences the brain, every aspect of our physiology, of our biology. So it really is an interesting vantage point to take and lens through which to look at all of the other different facets that comprise human health. And so this is just to show you that this is not pseudoscience. This was actually published in The Lancet in 2020. The Lancet is one of the highest impact factor journals that we have in the field of medicine. The potential for prevention is high. We've identified at this point 12 modifiable risk factors, suggesting that at least 40% of dementia cases worldwide are preventable. And I would say probably way higher than that, but this is where the consensus currently stands. So generally speaking, nutrition is the process of providing or obtaining the food necessary for health and growth, right? Fairly basic. I think everybody is generally has a sense of what nutrition really means. And so nutrition is really important, and it can be as simple or as complex as we want to make it, right? And we're going to kind of scale that hierarchy over the course of this seminar, of course. But yeah, it's a super empowering science. I happen to love it. I think it's really it's a fun science to discuss because it's relevant to all of us, right? There's not one of us for whom nutrition is not relevant, and it continues to be relevant across the age spectrum, and it changes also across the age spectrum. It changes depending on what gender you are to some degree. It changes depending on what your goals are. So, as you might hear me repeat a few times, there's no one-size-fits-all nutrition plan for everybody. Nutrition is not a hat. It's something that again, it's not one size fits all. It's bespoke. We have to think of it that way. I think a very common mistake that you see on social media, in diet books, is that people tend to present nutrition as if it is this sort of one size fits all science, and it's not. It's incredibly complicated. And for that reason, many people actually consider nutrition to be a quote unquote soft science. It's not something that we can measure in each person the effects of with pristine accuracy, the way that we can the laws of physics, for example, or geology or other such sciences. It's very difficult to study. It's actually much harder to study than drug research, and it's much less well-funded. So in my view, there are many aspects of nutrition science that actually we have to kind of think outside of the realm of science for answers. We have to use logic. We have to use common sense. We have to use reason. And so, yeah, I think that's a crucially important way to think about this. And then, of course, there's food, the purpose of food. And the role that food plays in our lives is a lot different than the role that nutrition plays, right? Nutrition has a very simple definition. Nutrition is all about making us feel good, setting us up for the best possible health, right, that we can have. But food plays many other roles, right? Food is how we celebrate, right? It's how we bond with one another. Cooking a meal for loved ones, it's like an incredible way to show love, to communicate that we love the person that we're sitting across from, right? We experience joy with our food. We have rituals associated with food. When we are stressed out, we reach for our favorite foods, right? So food, in a way, is like our friend when we're stressed or going through uncomfortable life events. So, I mean, food is something that we can't necessarily break down to nutrition and distill to its component parts, because it plays such an oftentimes ineffable role in our lives, right? A role that can't properly be described with words. There's like culture associated with food, right? Personal preference. There's so many aspects of it that are, again, personalized, that are individual. The problem is that our food supply has become super industrialized. And I think this is one of the major reasons. This is not just opinion, but our industrialized food supply is one of the major reasons, the foundational reasons why so many of us are unwell today, struggling with our health. Our food supply has become overrun with what are referred to as ultra-processed foods. Now, it's really important to make the distinction between the different types of food processing, right? So most people, when they think about food, they think it's either processed or unprocessed. But there's actually a continuum of processing, right? When you buy an apple in a supermarket, that's an unprocessed food, right? The second you slice the apple with a knife, you are processing it to some degree, right? You take that apple slice and you squeeze it, you create apple juice from it, you're processing it even further. You use that apple slice and you create applesauce, you're processing it even further. You take the apple and you make apple-flavored gummy treats with it, you're processing it even further. So food processing is a continuum, and at one end we have ultra-processed foods, which is a term that I'm going to come back to again and again. And at the lower end of the spectrum, you have unprocessed foods, and then just above that, you have minimally processed foods. One of the primary issues today, and ultimately one of the defining characteristics of the standard American diet, which is no longer just the standard American diet, but it's now in many ways the westernized diet is how it's often referred to, because we've essentially exported it to other nations around the world, is that our food supply has become ultra-processed. And typically there are a few ways to recognize ultra-processed foods. We'll get into that. But generally, where you find them in the supermarket is in the aisles. So, you walk down the aisles of most major supermarkets, and the shelf-stable, packaged, processed foods with seemingly infinite shelf lives, those are the ultra-processed foods that I'm talking about. And these are the kinds of foods that people are now over-consuming, indeed, ultimately basing their diets around, to the tune of about 60% of your average adult's calories today come from these kinds of foods, ultra-processed, shelf-stable foods. We'll get into the consequences of that. For children, that proportion is even higher. It's about 70%. There was a great photo essay that was done. I don't actually know the name of the photographer, but some photographer did a project where he went around the world and he looked at a week's worth of groceries for your average family. And this is a family in the UK. And they're a week's worth of groceries for them. And you have to squint to see the unprocessed or minimally processed food. I mean, you can see some fruits over there, some whole fruit on the right side of the screen. But generally, the majority of items that you see in this photo are of the packaged sort. You see the Capri Sun, you see the cereals, you see the bags of chips. This is a UK family. In the US, it's not much different. In fact, it's probably a little bit worse. Barely any fresh food. You've got, pizza, which is like a hyper palatable mixed dish. loaded with, probably innumerable industrial chemicals. You've got soft drinks and sodas. I do see some meat over there. But generally, this is how most Americans are eating. Just an overabundance of ultra-processed foods. We'll talk about some of the consequences, but just to give you guys a sense, we are now seeing the connection made between the consumption of these kinds of foods and chronic disease, which, it's pretty obvious, but it's always good to have data. This is a study that came out actually very recently, last year, middle of last year, linking directly ultra-processed food consumption with risk of dementia. We see that for every 10% increase in ultra-processed food consumption, there's about a 25% increased risk in the development of dementia. So, yeah, it's no bueno from the standpoint of brain health, but there are other consequences as well. When it comes to nutrition, there are a few major, I guess you could call them tent poles that really that we want to think about, basically. Like the more essential sort of tenets of nutrition come down to nutrients. As I mentioned, that was one of the defining aspects of nutrition. And when it comes to nutrients, we can generally break them apart into a small number of distinct categories. So the first one that we'll talk about are macronutrients. Macro means big, so these are like the big nutrients that we generally get from the foods that we eat. And generally speaking, the three macronutrients are carbohydrates, fat, and protein. Now, each of these can be broken down further. So carbohydrates aren't carbohydrates necessarily, fats aren't fats, protein isn't protein. The fats that you eat don't necessarily become the fat in your body, even though they have the same word. And there are many different types of carbohydrates to consume, and protein quality differs. So we're gonna break down these into the nuanced details. But just off the top, when people say macronutrients, generally they're referring to one of the three, one of these three categories: carbohydrates, fats, and proteins. Now, when it comes to essential nutrients, essential basically means that we need them to survive. And if we don't get them, we're going to develop a deficiency disease. There's no such thing as an essential carbohydrate, which isn't to say that carbohydrate inclusion in the diet isn't optimal. Carbohydrates are great. We need carbohydrates to optimize many aspects of our biology, but you wouldn't develop a deficiency disease by not consuming carbohydrates. Fats, on the other hand, are essential. Certain fats are definitely essential. You might have heard of the essential fatty acids. And that is actually a very, relatively speaking, there's a very small amount of essential fats that we need on a daily basis. We need to ingest certain fats like omega-3 fatty acids you might have heard of, omega-6 fatty acids on a daily basis. And those are the only fats that we need to ingest, which isn't to say that adding more fat to the diet isn't essential either. We see that higher fat diets are associated with better hormonal profiles and the like. But again, we're talking about the difference between essential versus non-essential. And then protein is absolutely essential. Protein provides amino acids, and your body is made of protein. So when you ingest protein, your body disassembles those proteins into its constituent amino acids. There are dozens of amino acids to list, but of note, there are 9 essential ones. And we're going to talk about where to find those. So essentially, protein is absolutely essential. Certain fats are essential, and there's no such thing as an essential carbohydrate. But the proportion that you want to include each of these in your diet, again, varies person to person, depends on goals. And yeah, what is not necessarily essential isn't necessarily suboptimal. So we just want to be clear to make the distinction between the way that we talk about these different nutrients. When it comes to carbohydrates, we have simple carbs, complex carbs, and then fiber. Fiber is a form of carbohydrates. We used to think that there was a big difference biologically between simple carbs and complex carbs. Like Simple carbs, I think most people past a certain age are pretty familiar with the fact that simple carbs are often used to describe sugars, simple sugars. And added sugar specifically is certainly not healthy, but what we're starting to see is that the difference biologically between consuming simple carbohydrates and complex carbohydrates isn't always as black and white as one is bad, the other is good. Complex carbs can often be easily broken down by our bodies almost as quickly as simple carbs are, and so the difference is kind of moot, particularly in the context of a mixed meal. But just so you know, simple carbs generally sugars, things like that. You can taste them on your tongue; they taste sweet. Complex carbs don't immediately taste sweet until they start getting broken down on your tongue. They're generally starches and things like that, found in fruits and vegetables primarily. And then fiber is technically a carbohydrate, but fiber we don't break down. And actually, something that should be said about both fats and carbohydrates is that they're both energy. So you can describe them both as providing energy to the body in different ways, but ultimately they're both energy. Protein isn't generally used as energy in the body. Protein is a building block. Carbohydrates and fat both generally can be pretty easily stored as fat. Fat is the most easily stored as fat, and then you get carbohydrates, and then protein is the most difficult for your body to store as fat because protein isn't really an energy source, and your body wants to silo energy for later if you provide it with an excess of energy. But fiber doesn't really provide energy. Fiber is generally thought of as indigestible, and instead it plays other roles. It fills us up, it makes us feel satiated. We know that it's beneficial because of the role that it now plays in the health of our guts, gut health and the gut microbiome, which we're going to talk about. But fiber is generally found primarily in whole plants, fruits, vegetables, things like that. And we see that fiber consumption is generally associated with longevity, lower levels of inflammation, and generally thought of as being good for you. I just want to be clear that there's no such thing as a one-size-fits-all diet. Many people generally have different fiber tolerances, but it is generally thought to be very beneficial from the standpoint of longevity. But we can talk about why fiber is thought to be beneficial. So next up we have fat. So as I mentioned, there are certainly some essential fats. It's kind of unfortunate that fat, we refer to as fat, and we also refer to the fat on our bodies as fat because a lot of people are under the misconception that fat makes you fat. It doesn't necessarily, although it can if we overconsume it. But underneath the umbrella of fat, we have different types of fats. So we have saturated fats, and even under saturated fats, there are many different types of saturated fats. So a saturated fat, we've been told for decades, are unequivocally bad for us, right? The evil saturated fats. But there are many different types of saturated fats, and not all saturated fats affect our biology the same way. For example, we have saturated fats in animal products like red meat, like the steak that I had this morning for breakfast. There are saturated fats in dairy. There are saturated fats found in plants, like coconut fat is predominantly saturated fat. And they all impact our biology differently. So if you ever hear anybody say that saturated fats are bad, unequivocally bad, they probably don't know what they're talking about. For example, among saturated fats that are commonly found in animal products, there are 3 primary saturated fats that you'll find: palmitic acid, myristic acid, and stearic acid. Stearic acid is an example of a saturated fat that's commonly found in animal products that has little to no impact on biomarkers associated with cardiovascular disease. And yet you'll hear again and again, saturated fats are bad. Also, dairy as a food category has the highest proportion of saturated fat of any other food category. So actually, this is pretty interesting. Wherever you find in nature saturated fat, wherever you find any natural food source of fat is going to have some combination of all of the different types of fat. Some are going to have more saturated fats, some are going to have more unsaturated fats, but in general, they tend to arrive like an entourage, but in different proportions. Dairy has the highest proportion of saturated fat. It's much higher than beef, it's much higher than pork, and yet we see consistently in the observational literature that people who consume full-fat dairy tend to have better cardiometabolic health, which is a paradox, right? I mean, if saturated fat is so bad for us, wouldn't you see people that regularly consume full-fat dairy just dropping off of like heart disease left and right? You don't see that. In fact, you see that they have better cardiovascular health. And that's thought to be due to the way the fats in dairy are sort of packaged as part of the food matrix, which is something that we'll talk about. The other thing about saturated fats is that they are the most chemically stable of any of the other fats, meaning they are the most resistant to a form of chemical degradation called oxidation. Due to their chemical nature, they're able to stack together very tightly. And this is the reason why saturated fats generally are solid at room temperature. It's just the way the chemical chain is organized with saturated fats. It's why they're so chemically stable. The fatty acids are just packed together very tightly. It's one of the reasons, and it's why they're solid at room temperature. And from a dietary standpoint, anytime you see something that is a fat that's solid at room temperature, we call that a fat, right? We don't call them oils. We call them, like butter is referred to as a fat as opposed to an oil. Oils tend to be liquid at room temperature, and they are primarily comprised of unsaturated fats. Unsaturated fats, generally speaking, are less chemically stable than saturated fats. What gives them that chemical stability are what are called double bonds. It just makes them more stable, less prone to this oxidative process. And the number of double bonds that a fatty acid has basically indicates its degree of unsaturation or saturation. So a fat with no double bonds is going to be saturated, and a fat with a double bond or more is going to be unsaturated. And so among the unsaturated fats, we have monounsaturated and polyunsaturated. Now, mono, as the name suggests, is means one, singular. So monounsaturated fats have one double bond. Polyunsaturated fats have more than one double bond. Of the unsaturated fats, monounsaturated fats, because they are more saturated, meaning they have fewer double bonds, they only have one, they're going to be more chemically stable than polyunsaturated fats. So again, saturated fats, the most chemically stable. Unsaturated fats are going to be less chemically stable than saturated fats. And among the unsaturated fats, monounsaturated, more chemically stable because it's essentially more saturated. And then polyunsaturated is going to be the least chemically stable. This is relevant to our biology. It's relevant when it comes to food, because generally speaking, foods that are higher in polyunsaturated fats, or I should say food products that are higher in polyunsaturated fats, are going to be more prone to this form of chemical degradation, which can affect your biology in profound ways. Now, when it comes to whole foods, you don't have to worry about this distinction. This is a distinction that only really becomes relevant when we're talking about processed foods, because wherever you find these fats in nature, nature has done the guesswork for us. Nature has packaged these fats with the appropriate amount of antioxidants to protect them. So again, in nature, wherever you find polyunsaturated fats, which as I mentioned are chemically unstable, monounsaturated fats, you always will find a requisite amount of antioxidants to protect those fats. For example, in walnuts. Walnuts are a very rich plant-based source of polyunsaturated fats, chemically very unstable, right? So does that mean that walnuts are unhealthy? No, because walnuts are also a very rich source of vitamin E. Wherever you see polyunsaturated fats in nature, you also are going to see a requisite amount of, a requisite concentration of vitamin E to protect those fats. The problem arises in processed foods where you have polyunsaturated fats that have been extracted from the food matrix and don't necessarily have that antioxidant protection. And then that's where you run into problems that we're going to talk about. But generally, those are the two primary sources of fats that you consume: saturated and unsaturated. And then we have trans fats. So underneath the umbrella of trans fats, we often hear are really bad for us. And generally speaking, that is true. They are very bad for us. And that's because the primary occurrence in the diet where they would appear historically would be in the form of partially hydrogenated vegetable oils. Does anybody remember those? Show of hands. They were actually very commonly used in processed foods up until, I believe, about 10 or 15 years ago, when the FDA banned them. But they were in the food supply, the Western food supply for decades because they were thought to be a healthier alternative to saturated fats. They behave similarly to saturated fats, but they're artificially manipulated so as to behave like saturated fats. And what manufacturers would typically do, they would take unsaturated fats, like polyunsaturated, like vegetable oils, and they would pump them full of hydrogen so that they would behave more like saturated fats. And, for the past few decades, the tide is beginning to turn, but we were told again and again that saturated fats were not good for us. They were demonized to a large extent by our governing bodies. And so a food manufacturer could give processed foods the texture, the consistency of food that was otherwise rich in saturated fats, but market it as being low in saturated fat. And so it was also, they were dirt cheap to produce. So, unlike butter or tallow, partially hydrogenated fats they cost, nothing to produce essentially. And so very appealing from a food processing standpoint. We now know that those kinds of fats are poisonous to the cardiovascular system, to our brains. And so, those have been essentially outlawed, although they still exist in the food supply. And I'll talk about that. I'll talk about where we can still presently find them later on. But an important distinction needs to be made. Trans fats are also naturally occurring to some degree in other forms in animal products. So certain dairy products and the fat of ruminant meat also contain naturally produced trans fats, which are actually thought to be beneficial. The data is not super strong on this, but we see that they are different than the kinds of trans fats that were man-made, artificially created. And so one example of a naturally occurring trans fat is referred to as CLA, or conjugated linoleic acid. It's thought to have some anti-cancer properties, some metabolism fortifying properties. It's been associated with fat loss, although I think that the data on that is pretty weak. But CLA is an example of a naturally occurring trans fat. And again, it's found primarily in the fat of ruminant animals and the dairy produced by those animals. And then protein. So protein is one of my favorite topics. Protein is super, super important. As I mentioned, it's essential. We're going to talk about protein timing and protein dosing and all the cool, fun, relevant stuff with regard to protein. But essentially, protein is what most people think of when they think of meat. Meat, eggs, dairy, things like that. We find protein in plants as well. It's actually there's a misconception that plants don't have all of the requisite amino acids, that plant proteins are essentially incomplete. Animal proteins do provide all of the essential amino acids in their appropriate amounts, in their plug-and-play amounts. Their animal proteins are the highest quality proteins that we find in nature, primarily because, we're meat and we're not ruminant animals, as I mentioned. So when we ingest the meat of another animal, it helps to fortify the meat that we're made of, which is kind of a weird way to think about it, but it's kind of how it works, Plant proteins, all plants have all of the amino acids, but they have them in varying quantities. Now, if you're consuming enough protein on a plant-based diet, that becomes moot, so long as you're consuming a diverse diet, a diverse array of plant proteins. But that's not something that you need to be concerned with when you're consuming animal protein, because it provides the appropriate ratios of all the different amino acids to promote human health. But again, plant proteins, you'll find certain plant-based sources of protein that are low in certain essential amino acids, and then you have to combine them. People on plant-based diets will often combine grains with legumes and things like that. Plant-based protein powders, you'll often see pea protein mixed with rice protein and things like that. So you do have to kind of cobble together different protein sources on a plant-based diet, but in the context of a diet that contains adequate protein, generally not something that you need to worry about. Also, plant protein in the context of an omnivorous diet, so if you do eat animal protein and you're consuming plant protein as well, that protein does count, because at the end of the day, all proteins are broken down into its constituent amino acids. And so, you might be getting less of a certain amino acid when you consume a certain plant that you're getting more of in another food. So ultimately, it all comes out in the wash. And the more varied and diverse your diet is, particularly if it's an omnivorous diet, you don't have to necessarily worry about protein quality so much. Where protein quality does become an issue is for people that are on restrictive diets. So for vegans, protein quality definitely becomes an issue, and particularly for people on low protein diets. So the less protein you consume, the more you want to make sure that the protein quality that you're consuming is sufficient. And animal protein, again, is always at the top of the list in terms of protein quality. But this becomes really important for certain populations. For example, anybody who's on a lower protein diet, older populations, so older adults, like elder adults, tend to underconsume protein, and so protein quality, making sure that they're consuming adequate protein is a really important consideration. This shouldn't be construed as medical advice, but people who are on protein-restricted diets for medical purposes, you want to make sure that you're getting high-quality protein. So if you're on a low-protein diet and you're consuming, plant protein, and you're not doing it thoughtfully, you could run into trouble. The third type of protein of note would be collagen. So collagen is actually the most abundant protein in the body. We now see it on the market in terms of numerous supplements. Collagen is not thought of as an essential protein because we produce it. But that being said, there is mounting evidence to suggest that by eating more collagen, we see benefits to our joints, to various aspects of our physiology, like wound healing. My dad actually recently had a total knee replacement surgery, and my dad is very supplement averse, but one of the supplements that I got him to take was collagen because there's evidence that collagen can support wound healing. Collagen comprises the molecules that keep our arteries elastic, so it's a super important protein. that's not necessarily essential, but again, we see benefits when we consume more of it. Collagen is essentially a repeating loop of 3 amino acids, which you don't really have to remember, but glycine, proline, and hydroxyproline. It also contains a little bit of the essential, it contains a few of the essential amino acids with the exception of tryptophan. So collagen is actually, unlike plant protein, you actually are lacking in tryptophan with collagen. But again, in the context of a diet with enough protein and with food and protein diversity, you would count collagen as your protein, as part of your daily protein intake. And we actually see that glycine, which is one of the primary parts of collagen, 1/3 of collagen is glycine, actually plays a number of important roles in the body, independent of the role that it plays in collagen synthesis. We see that glycine is important for metabolic health. It can actually be used to improve sleep. There have been a small number of studies that have shown that glycine before bed can actually boost sleep quality, certain measures of sleep quality. So collagen is pretty great. It's found primarily in the ligaments and connective tissue of animal products, organ meats and things like that, which we used to consume a lot more of. Today we tend to consume more the skeletal muscle of animals. And some people believe that we're actually missing out by not ingesting more collagen on a regular basis. So it's definitely, I think, a worthwhile form of protein to ingest. And yeah, I'm a fan. And then, of course, we have supplements. Collagen is widely available now as a type of supplement. We see them on the market as collagen peptides. But there's also other protein supplements that are more complete in their essential amino acid profile. And my favorite protein is whey protein. Whey protein supplements are great. You also have plant protein supplements on the market. In general, what I will say is that whey is the highest quality protein. It's extremely high quality protein. It is a processed food, but it's made in the cheese making process. And so I would consider it minimally processed, and I would consider it actually one of the few exceptions where ultra processed or where processed foods actually are, you can actually get like a really healthy product with food processing. So not all food processing, that is to say, not all food processing is bad. There are definitely examples of processed foods and even ultra processed foods where you actually yield a very healthy product, and whey protein supplements, I think, are an example of that. And then you also get plant protein supplements. Now, plant protein supplements are a lot more processed, and they tend to harbor heavy metals, which is a problem. The dose of heavy metals that you're ingesting when you ingest plant protein supplements might not be all that concerning, especially if you are not ingesting it all the time. But people on vegan diets are consuming lots and lots of plant-based protein supplements, and so for that population, it could potentially be a concern. But in general, I'm a fan of protein supplements. And you don't need to be a bodybuilder to reap benefit from protein supplements, I will add. So in general, I'm not a huge supplement guy, but protein supplements are great. So with all of the variables that we talked about in this portion of the seminar, these are all variables that can be tweaked for better health. Fat, carbohydrates, we're going to get into all of it, but just wanted to sort of like lay the groundwork and establish some definitions before we dive in. But we are made of food. Like the foods we eat, you are what you eat, essentially. And food is a form of information. It has epigenetic capacity, meaning that it actually can change the way your genes express themselves, which is super cool to think about. And we see now that many of the kinds of chronic diseases that people are suffering from around the world, cardiovascular disease, cancer, dementia, are responsive to food. Many people say that food is a form of medicine. I would agree with that. I think we just have to be mindful of what food can and can't do. If you have a chronic disease, I think that the capacity of food is limited. But where its power really shines is with regard to prevention and management to some degree. So I'm a huge believer in the power of nutrition, and we're going to dive into all of this stuff. We also know that food is super important from the standpoint of body composition. Body composition matters. The ratio of muscle to fat mass that you're carrying with you, all super, super relevant when it comes to long-term health, how you feel, and food plays a major role in that. I hope to share with you guys ways of optimizing your body composition. And yeah, there's a ton to talk about there, which we're going to cover. And then, of course, the role that nutrition plays in exercise performance. Now, I come at this as somebody who's not an athlete. I'm not a superstar athlete or anything like that. And I think that knowing how to harness the power of nutrition to augment the effort that you're putting in the gym, super important. So we're going to talk about all that stuff. But yeah, that's it for this portion of the introductory portion of my seminar.